In this video, we're going to look at the cumulative binomial distribution function, but specifically we're going to focus on questions that involve working out the probability of more than a certain number of successes occurring. Let's have a look at this example. So a manufacturer supplies DVD players to retailers in batches of 20. It has 5% of the players returned because they are faulty. Find the probability that a batch contains more than 4 faulty DVD players. So as with all the previous questions, we should start by writing down what the distribution is. So that's the number of faulty DVD players, has a binomial distribution. There are 20 players in a batch, and each player has a 0.05 chance of being faulty. The question is this: what's the probability that more than 4 are faulty? Now, in order to solve this, we need to convert this into a less than or equal to function or question. The reason for that is that calculators, at least the calculator that I'm working with, the most common ones, only have a cumulative function. That's only a less than or equal to function, not a greater than function. Now, if you have a graphical calculator, it probably does have the option to do more thans and more than or equal tos, but you still need to be careful. You still need to set it up correctly. So I recommend, at least in the early stages, that you always begin these by just listing out the numbers, which is basically just writing 0, 1, 2, 3, writing out some numbers first. At least cover the kind of range around this. Now, it's more than 4. So here's how I like to do this. More than 4, I kind of circle the ones I want, and then I think which ones don't I want, and I put a little squiggly line under them. So I don't want these. So what I can say is the probability that x is more than 4 is 1 minus the probability of the stuff I don't want. And the stuff I don't want is less than or equal to 4. So I've turned my more than problem into a less than or equal to problem. And that I can solve in the calculator because I go to my menu, distribution, my binomial cumulative, and my variable. And then I can work out the probability of less than or equal to 4 by saying it's less than or equal to 4, number of trials is 20, probability of success is 0.05, and there's my answer, 0.9974. And so what I want to do now is I want to do 1 minus that. So 1 minus 0.99, I've already forgotten it, 7426. 7426. Working this out, that's 0.002574. So there's our answer to 4 significant figures. By the way, little calculator tip here. An easy way to work this, rather than kind of writing it all down like this, is to store this number. So I've showed you in previous videos that storing can be useful. It's really useful here, because if I go to store and then let's store it as A, now it says stored as A, and this number is now A. So if I come out of this mode, so menu and then 1 to get back to my normal calculator mode, A is sitting waiting for me there. And so now I can just come back and do 1 minus A and get my answer there. It's given in standard form here. But that can be a really useful way to get precise answers nicely on the calculator. Okay, let's have a look at another example. The probability of a bolt being faulty is 0.3. Find the probability that in a random sample of 20 bolts there are more than 3 faulty bolts. So the distribution, so the number of faulty bolts, is a binomial distribution. There are 20 of the bolts, and the probability of them being faulty is 0.3. And the question is, what's the probability that the number of faulty ones is more than 3? So remember, we should write out some numbers. This is just to ensure that we get this bit right. The reason I suggest doing this is that from my experience teaching this, it's so common for people to get the step wrong where they transform this into a less than or equal to question. So it's so common for that bit to be messed up. So just take the time to write out some numbers, think through it, get that bit right. Because if you get this step wrong, you tend to lose quite a lot of marks. So it's good to take the time to get this right. So more than 3. So we want the ones which are more than 3, which is this. So not including 3, because that's not more than 3. Now here are the ones that we don't want. So we phrase this as 1 minus the stuff we don't want. 1 minus the probability that x is less than or equal to 3. So I can go to my calculator, go back to my distribution mode. It's the binomial CD, the cumulative, it's variable, and x is 3 because it's less than or equal to 3, n is 20 because it's 20 trials, and p is 0.3 because that's the probability on each one, and there's my answer. So it's going to be 1 minus that, 1 minus 0.1070. You see how I forget it? 9, and then rather than do this, I'll go over again how to store our answer here. So if I store this as A, that number is now stored as A. If I come back to my regular mode, I can do 1 minus A, and there's my exact answer, or more exact answer, 0.8929. 0.8929. So there we go. That's how we can use the cumulative function on the calculator to solve some really quite tricky problems, and ones that would take an awfully long time if we did it by hand. And whenever you can use the calculator in this topic, you should, otherwise it will take too long. Hope that's been useful. I'll see you in the next video.